Hello, this is Python Statistical. Today we're going to be looking at the Python method os.walk. This allows us to read files in from a directory and subdirectory which I have called more data. This allows us to automate the process of reading separate files into Python and thereby being able to perform analysis on an industrial scale. I wrote a function called getAllData, and it will feed in the data path where those files are stored, which is here, the top directory path. I then import pandas as PD, as we're going to store the spreadsheets as pandas data frames, and then I import OS to be able to use the Python operating system interfaces. I then define an empty dictionary, file dictionary. This is where we'll store all our pandas data frames corresponding to each file. And then we define an empty list file list that will be used to store the full directory path and the file name. So we next have this for loop to walk through our directory and subdirectories. And so we need the parameters directory path, subdirectory name, file names, and then to call os.walk is just os.walk. Data path corresponds to the directory path where the data is stored, whether we start from the top of the directory structure or from the bottom. So the default is set to true for top down, and follow links is set to false as a default, so we don't have to worry about that. Next, I just print these parameters and we can see what's going on. And then we have another for loop as file names is a list, and so we have to read each file name and we're going to append it to the file underscore list that will contain the full directory path and the file name. And to do this, we use os.path.join to join the directory path and the file name. And we will append each one so that it's saved in the file list, and so we have all the files in that file underscore list. I then have another for loop to loop through each of those files in file underscore list. I grab a catalogue number, as this is labour force statistics from the Australian Bureau of Statistics, and if we have a look at that, we can see that they have a catalogue number which corresponds to each table that is published. So to grab the catalogue number, I need to take the last forward slash, and I do a right split, and then I take the last part of that, which will be that catalogue number plus the extension. So that's why I have -1. So I'm taking the last string, and then I have to strip off the extension, which I do here with the .strip method. So I'm stripping off the .xls extension, which is the Excel spreadsheet extension. And then finally, I store the actual spreadsheet as a pandas data frame, and I use the catalogue number as the key for that dictionary. In addition, I'm reading it from sheet 1 because sheet 0 is not where the data starts. It starts in sheet 1, and I specify no header. I then calculate the number of files using just the length function of that file list, which will correspond to the number of files that are in this file list. And then I print the number of files that we have, and then I print that file list so we can see all the files that we have. And then I return the file underscore dictionary, which is what will be produced once I run the function. And so in line 62 to 65, I call the getAllData function, and I save the file dictionary as all underscore files. So let's run this program and see what it does. So it's printed the directory path. So we go back here. It's printed the directory path which is the top directory structure, and then it tells me that there is a subdirectory called more data, and then we can see that once it moves to that subdirectory, it says there's no further subdirectories, and that's why subdirectory name here is empty. It also tells me that we have 19 spreadsheets, and then we can see that the list of files contains the full path plus the file name, so that's the file name there. So let's take a look at that file dictionary, which we called all_files. So we go to Variable Explorer, double click on the dictionary, and here it is. So I'll just expand that. So if we open the first key, which is the Australian Labour Force Statistics for Australia, we can see that we have our data, we have the column descriptor for each of our columns, and then our data starts in row 10. So as we can see, all our spreadsheets are now stored as pandas data frames in a dictionary, and we can access them using the key. So this brings us to the end of this video. If you liked it, give it a thumbs up. If you disliked it, give it a thumbs down. And if you really like it, please subscribe to Python Statistical. I will also be attaching this Python code in my Patreon site, which will be available to all my patrons. And thank you for watching.